Welcome to qnawire.
When 10.1 grams of magnesium reacts with 10.5 grams of oxygen gas, O2, the reaction produces 11.9 grams of magnesium oxide. Determine the limiting reaction, theoretical yield in grams, and the percent yield for this chemical reaction. You need to show all calculations, and 2 magnesiums plus O2 in grams gives us 2 magnesium oxide. So, when the reactants and product react with each other, then the respective mass of every element is conserved throughout the reaction. Stoichiometry is the relation between the quantities of reaction reactants, which works on the principle of the law of conservation of mass. So the reaction is written as follows. Two magnesium plus O2 yields 2 magnesium oxides. So the S stands for solid, the G for gas. So 2 magnesium, and it's a solid, plus O2, which is the oxygen, and it's a gas, yields 2 magnesium oxides, which is a solid. And we have the given data. The mass of magnesium is 10.1 grams. The mass of oxygen is 10.5 grams. The molar mass of magnesium is 24 grams. And the molar mass of oxygen is 32 grams. The number of moles is calculated as follows. So the number of magnesium moles is the given mass divided by the molar mass. Using substitution, the given mass is 10.1 grams, and the molar mass is 24 grams per mole. And when we take that 10.1 divided by 24, we get 0.42 moles. And we're rounding to 2 decimal places. And then we have the number for O2. And again, it's given mass over the molar mass. Using substitution, I get 10.5 grams divided by 32 grams per mole. And 10.5 divided by 32, I get 0.33 moles when rounded to 2 decimal places. As per the reaction, 2 moles of magnesium react with 1 mole of oxygen. Therefore, 0.2 moles of magnesium will react with 0.21 moles of oxygen. The quantity of oxygen is 0.32 moles, which is in excess. Therefore, magnesium is the limiting agent. So magnesium is the limiting reagent. We're going to determine the theoretical yield. The actual yield of magnesium is 11.9 grams, and the theoretical yield of magnesium oxide is 16.83 grams. The percent yield can be calculated as the actual yield over the theoretical yield times 100 to give us a percentage. Using substitution, I get 11.9 grams divided by 16.83 grams. And I get 0.707. This was times 100 times 100, which gives me 70.7%. The percentage yield for the reaction is 70.7%.